Good morning. This is Sharan Uthani from Vellore Institute of Technology, Chennai. Today I'm going to present my digital image processing project, course code BCSC 403L, under faculty Dr. Geeta Balan. The topic of our project is enhancement of low quality diatom image using integrated atomic background removal method from digital microscope. So, a diatom is a diverse group of microorganisms that are typically autotrophs, organisms that can affect the quality of water by altering its color and taste. They are used in many forensic research, and due to this tiny size, can only be observed under a microscope. However, images that are captured under a microscope suffer from issues such as noise, blur, stain, and background distraction. Due to this, we have to come up with a solution to enhance the image and remove its background. So the primary objective of this project is to enhance low quality microscopic image of a diatom using an integrated approach that includes background removal. By doing so, we have to improve the clarity and visibility of a diatom structure and make the image more suitable for accurate analysis, identification, and segmentation. This enhanced visual quality supports both manual and observation and automated background processing tasks. So currently there are many existing works on this field, such as clay, toboggan contrast enhancement, MTF. However, solutions such as clay improve contrast while limiting the noise but has poor edge enhancement and high computational power. Similarly, TCE and MTF also suffer from poor edge detection. So our solution to this is integrated background removal method, which offers a robust solution to enhance low quality diatom image captured under digital microscope. IABR ensures precise, clean visual, enabling better scientific insight and efficient computational tasks. So this is the proposed architecture of our IABR solution. And now I'll be explaining the working of IABR. So it works in two steps. First is haze removal and second is background removal. In haze removal, we improve the image quality by reducing noise and haze. And first, it converts the image to its invert negative form. Second, it applies dehazing algorithm which reduce haze and enhance brightness. And then it inverts the image into its original form, but now with improved clarity. The second step is background removal. It isolates the diatom from unwanted background elements. This it goes in this way. It detects the edge, identify the region of interest, apply morphological operations such as erosion and dilation, help in distinguishing the diatom from its background. Remove background, convert a non-diatom area into plain background, and enhance contrast, improve visibility by adjusting brightness and contrast. So the original image and enhanced image are compared on the Fallen matrices, which is entropy, which measures the information content or randomness in an image, average gradient, which is a measure of sharpness and edge intensity, universal image quality index, which is measure structural similarity between original and processed image, and PSNR, which is peak signal to noise ratio, which is measure of pixel-wise fidelity to the original image. So now I will be demonstrating the working of IABR through this code. So as you can see, we have obtained three images, which is first the original image from the data set, from the trained data set, then the enhanced image and the image with background removal. So we are performing background removal using GrabCut method and enhancement using IABR. So after enhancing the image, we are comparing it over the following matrices, which is Shannon's entropy, mean gradient magnitude, universal image quality index, and peak signal to noise ratio. So as you can see, the image has been enhanced in the following ways.
Good evening. My name is Yash Srivastav, and I'll be demonstrating this project. So this is our Clahe code. These are the, as you can see, these are the matrix functions we have created to calculate entropy, average gradient, UIQI, PSNR, and EBCM values, which are according to our research paper. And then here we took the image from the data set, and we convert it into the lab format because it helps us retain the color of the image. And then we apply the Clahe. Now I'll run this code for you and show the output. So this is our original input. This is the background removed output, and this is the enhanced image output. So for the background removal, we are using grab cut method, and for the enhancement of the image, we are using Clahe. And these are the metrics which we calculated using this. So now I'll show you the difference between the Clahe and the IABR by running this difference code. Uh, so we have also calculated the metrics required to distinguish between both the methods and prove which one is more efficient. So this is the Clahe output cell, this is the original image, and this is the IABR output cell. So as you can see, the Clahe output cell is less efficient towards the edges, and uh, whereas in the IABR cell, we can see the output cell is more efficient than the Clahe, and as we have calculated the metrics here, the entropy is higher in Clahe than IABR, but the gradients and the UIQI values is more in IABR, and to overall the EBCM value is much higher than the IABR. So, which makes IABR more effective than Clahe. So now I'll conclude the results uh, of this topic. So these are the results of the IABR, and these are the results of the Clahe which are shown. And this is the result between the IABR cell and the Clahe cell. So as you can see in the Clahe cell, the Clahe may produce unnatural results and can amplify noise in a few regions, but whereas in IABR cell, it preserves the natural brightness of the image, reduces noise amplification, and maintains better color fidelity. So therefore, the IABR cell gives more enhanced and natural look images than the Clahe cell. So here are the results which we have calculated in the code, and the conclusion of the topic is that the IABR method effectively enhances the diatom images by removing hairs, extracting the diatom from the background and improving contrast. So therefore we conclude our topic here, that is enhancing low quality diatom images using IABR and Clahe. Thank you.